nutrient pollution.
Why is atmospheric pollution important? Of the anthropogenic factors that affect the marine environment, there are some in which we cannot see. According to an article, the atmospheric deposition of nitrogen to coastal waters is one of many ways in which humans can influence the ocean. Nitrogen is essential in the growth of living things, especially in the marine ecosystem. However, too much can create large, uncontrollable algae blooms that deplete oxygen levels in the water. Not only that, but the overload of atmospheric nutrients, especially nitrogen, can affect geochemical cycles that can naturally happen in the ocean. These cycles include nitrogen, carbon, oxygen, and water.
So one way to fight atmospheric pollution is to reduce nitrous oxide. So nitrous oxide is a greenhouse gas, has a global warming 310 times stronger than carbon. At this point, one solution we could do is stop using cars and trucks. So at this point in time, I'm just walking. See you guys. There's a lot of agriculture around here. A lot of nitrous oxide, or half of the world's nitrous oxide, comes from agriculture. Another way to combat atmospheric pollution is to use stabilizing fertilizer products. In other words, nitrogen inhibitors, or products known as nitropyrene. By using these inhibitors, farmers in agriculture are allowed to maintain crop yields and sustain the environment for the future. This is what we have to say to you, nitrous oxide.
Alright.
You guys got nitrous oxide?
No.
No? No, they don't. Oh, nitrous oxide. No. Lastly, another way to resolve atmospheric pollution is to reduce industrial emissions of nitrous oxide. The reason for that is because it produces items such as nylons, synthetic material, just like this right here. First taste test. Well, I'll show them synthetic stuff right there.
Coastal zones are characterized by being preferred living areas, thus having significant amounts of nutrients deposition in the surrounding waters. The development of hypoxic zones and introduction of CO2 in seawater due to microorganisms' biological processes are two principal problems of the interaction of humans and the coastal environment. In recent times, fisheries are being affected by the development of hypoxic zones, and thus coastal management should focus in more aspects than just dissolve oxygen levels to fully protect marine organisms. Nutrient pollution itself can be tackled by environmental management practices and the correct implementation of sanity acts and programs. Eutrophication is caused by an excess of nutrients in seawater. The main sources of phosphorus in the oceans are runoff, excretion of organisms, and the diffusion across the sediment-water interface. An excess of phosphorus in seawater can lead to harmful algal blooms, which ultimately will deplete the oxygen from the water body, thus threatening the life of marine organisms. The rate of mineralization of organic phosphorus decreases as the pH levels decrease. This decrease in pH facilitates the flux of phosphorus from sediment to water, this playing an important role in the blooming of algae. The correct mapping of these blooms is key for learning how these organisms spread in the coast. Current technological developments such as nanotechnology could help to recognize these toxins. Sensors in conjunction with a photoelectrochemical technique could help to recognize low concentrations of these toxins created by cyanobacteria that could be found in drinking water.
Other causes of eutrophication include human-induced stressors such as overfishing, chemical contaminants, habitat degradation, and invasive species. Along with that, global climate change will result in an increase of water temperature, stratification, and an increase of inflow of nutrients to coastal waters across the globe. Along with that, the discharge of untreated animal manure is a major source of nutrients in rivers and coastal waters. One major source of this is runoff, which comes from point and non-point sources. Point source pollution comes from any source that empties directly into a waterway, such as a pipe from a sewage treatment plant, factory, or a home. Non-point source pollution comes from any source where runoff does not go directly into a waterway, such as urban, suburban, or rural areas. Farms are a major source of runoff pollution, and often rainwater and irrigation drain fertilizers and pesticides into the bodies of water. These can carry the fertile soil layer of topsoil away from farms, which rely on topsoil to grow their crops, and it will seep into their groundwater supplies. The effects of eutrophication include hypoxic or dead zones. These are areas in the ocean where the oxygen concentration is so low that animals can suffocate and die out. The Gulf of Mexico has the second largest human-induced hypoxic zone in global coastal waters. Possible solutions to eutrophication include backcasting models, which can provide key information to policymakers. These policymakers develop effective environmental policies, such as restricting the amount of synthetic fertilizers used by companies, and this will then limit the amount of excess nutrients in the waterways.
While eutrophication may be a global issue, there is no global solution. Every nation must work out their own ideas in order to come to a solution to this problem. I have two case studies I'd like to go over today, one being the eutrophication in China and the other being eutrophication in South America. Eutrophication in China is caused mainly by agriculture, both from runoff of excess fertilizer and leaching of fertilizers into groundwater. Runoff was tracked into the Yellow, Yangtze, and Pearl rivers, and that followed into the ocean. Over 200 field tests were done on fields to examine the nutrient levels before and after rain events. This showed that a very heavy loss of nutrients after every rain event, and they tracked the nutrients into the ocean. The article points out that the agricultural industry doesn't need to be using as much fertilizer as they have been, and thus a rather simple solution would be just to use less fertilizer. This can be done either through government regulation or market regulation by showing that we don't need the amount of fertilizer to make the same amount of crops. Another more efficient fertilizer could be used in order to create a better functioning agricultural system in China. A third possible solution is crop rotation. Crop rotation is simply when you switch out crops for another one during the season. It is often not done in China as they believe the most efficient crop is the one they're growing year-round. Eutrophication in South America, however, is caused from a mix of agricultural runoff and by poor water treatment. The agricultural runoff results in high nitrogen levels being leached into the ocean, while the poor sewage treatment causes for high levels of phosphorus. Studies showed huge impacts on estuarial waters. Sampling 40 different sites showed eutrophication in 39 of them and increased nutrient levels in all 40 systems. Eutrophication was also seen causing hypoxia and major fish kills in the region. Possible South American solutions are a lot more difficult to come by, as South America is a less well-off region. Richer countries could attempt to build better water treatment facilities, while poorer countries would just have to try to reduce the amount of nutrients that leach into the water in the first place. Poorer countries could also use subsidy programs, whereas they take money from more well-to-do countries such as the United States or European Union and use this money to create better water treatment facilities, have better fertilizers, or by using nanotechnology in order to remove the already present nutrients in the water.